All right, you're going to do, first we're going to work on this. Now, if they have the same base and they're multiplying, okay, you can simplify this. When they multiply, the exponents actually add. So x to the 7th, okay? Exponents always do one step lower than what you think they are. So here, like when they're dividing here, they have the same base and they're dividing, which means the exponents are actually going to subtract. So this is going to make x to the 3rd. Now here, distributive property with extra variables, we're going to work on it. So the 4 is going to distribute first. The 4 is going to multiply with this, which is, there's a 1, imaginary 1 here. So this is going to be 4, and then this one over here is going to be a positive, let's say 20 here. So 4 times 5 is 20. And then we're going to do the next one. So we'll do the x's now. X's go with x's. So x to the 3rd times an x is going to leave you with x to the 4th, because that's one x right there. So, and then the next one will be x to the 3rd times x to the 2nd. They're multiplying, which means the exponents are adding. So that's going to be x to the 5th. Then we have the y. We'll do the y in a different color. Okay, now we're going to do y to the 2nd times y to the 2nd. That leaves me with y to the 4th. Y to the 2nd times y is going to leave me with y to the 3rd. And then the z is all by itself. There's nothing having to multiply with the z, so the z doesn't change. It kind of just stays there. All right, and that's it. I like it. All right, so next one. How to graph these. So, if you do know how to graph these, and if it's set up like this in slope-intercept form, it's very simple. This is the start point, and this tells you how to find the next point. Okay, so -4 is where you would start. Okay, -1, -2, -3, -4. So you start at -4, and to find the next dot, you have to use this slope. Slope is written as rise over run. So we're going to rise 2 and run 3. And if I keep on doing it, I'll keep on running into points that are on this line. You only need 2 to really make this, but just so that I have a nice straight line, I did a couple extra. Okay, so that's how you would graph this one. Let's say you run into this one, and you don't remember how to move things, and you don't know how to graph it. Oh, how do I graph this? This is obviously linear because I don't see any squares, I don't see any square roots, and I see that x is not at the bottom of a fraction. So I think that this can be graphed just by plotting in a couple numbers. So plot in a couple numbers. The easiest number for me to always put in a formula is x equals 0, and then I can figure out y after. So if I put x equals 0 in here, I'm going to get 3 times 0, which is 0. So I'm left with just the 2y equals 6. Just so you know what I did, I put a 0 into x. So 0 into x. Now I have to figure out what my y is. So I have to leave the y by itself. I'm going to divide by 2, divide by 2. Y equals 3. So now I know that one of the spots is 0, 3. All I need is one more dot. I got to figure out one more number to put in here. Okay? Now, that is what we just found was the y-intercept. If I wanted the x-intercept, I could actually replace y with 0, which sometimes works out, sometimes does not. So let's check if it works out this time. I'm going to put a 0 into the y. Okay? So this is going to be 0. So it's going to be 3x plus 2 times 0 equals 6. 2 times 0 is 0. 3x plus 0 is just 3x. Right? Divide by 3, x equals 2. Now this doesn't always work out. You might have to put in a couple numbers to figure out something that gives you 2 whole numbers, but very, very good. So this actually is another dot. So now I have 2 dots on here. That's all I need. There's my graphed line. Very, very simple to graph something. Even if you don't know the tricks on how to graph it, you could plug in numbers and get the other letter. So I plug in an x and I solve for y. I plug in an x, I solve for y. Or I can plug in a y and solve for x. Also works, okay? So any of those scenarios work in this situation. It zoomed in too much. All right. right, slope. Now slope is a very, very easy process, okay? The formula is the change in y divided by the change in x, okay? So y's are always the second numbers, x's are always the first numbers, okay? So we have to find out what the change in y is first. So how did a 5 turn into a negative 9? It went down 5 to get to 0, and then went down 9 more times. So this went down 14 times. So the change in y is down 14. Then you have to ask yourself, how did a 3 turn into a 2? Well, it went down 1. So this one, the slope, is actually positive because a negative divided by a negative makes a positive. So 14 divided by 1 is actually just 14. That's the slope of the first one. Now, do the second one. You can pause it if you want to try it on your own. Okay, the change in y, 1 to 2, that goes up 1. And then negative 2 to 7, that goes up 9. So this slope is 1 over 9, rise over run. Now let's go to the next one. So now we're factoring these. So this one's pretty easy to factor, and we'll solve for 0 after we're done. So let's say we just have to factor this. So I'm looking for two numbers that multiply to make 14, but when you subtract them, they make 5. Okay, so two numbers that multiply to make 14, but when you subtract them, they make 5, 7 and 2, which means x is going to be in the first one of both. One of them is going to be 7, and one of them is going to be 2. Okay? The sign in the center is always the same as the biggest number. So it's going to be next to the 7. It's going to be positive. The minus sign means that the signs are different. So that means that this is going to be minus. If this was a plus, that would mean that both signs are the same. Not that they're both positive, that they're both the same. Okay? And this sign always is the same as the largest of the two numbers. If they're both the same number, you choose one. All right, so that was that. Ooh. If I asked you to solve for 0, the solutions would be, if I put negative 7 in this formula, it'll make 0. Also, if x equals 2, it'll equal 0. I factored and solved. All right, let's factor and solve this one. Now, before you start these, you see how there's a number in the front? Normally, this doesn't happen, but you see how everything's divisible by 2? That's cool, and that'll work out perfect for us. But we're not going to do that. We're going to pretend we didn't notice that, and we had to solve it anyway. So let's factor this correctly. So 2 times 6, that's going to make 12. Now we're looking for two numbers that multiply to make 12. Okay, it's positive 12. But when you add them, they make 8. So what two numbers multiply to make 12, but when you add them, they make 8? That's going to be, this is going to split into 2. That's going to be negative 6 and negative 2. X. If I put these together, what will it make? Negative 8x. When I multiply those two, a negative 6 and negative 2, don't I get a positive 12? I do. Everything else comes down. So you can see how this is slightly different than the last one. Now, we are going to put the front in parentheses and the back in parentheses. Now we're just looking for something they have in common. Here, they have a 2 and an x in common. So 2 and an x. So I'm going to take a 2 and an x out. Sorry, I forgot to bring out the 2. So that's going to leave me with just x here, and I'm going to be left with just 3 over here because I divided it out. I divided everything in here by 2x. Now I have to divide everything in here by something, but remember, this has to end up to be x minus 3. Right now it's something plus 6. What changes the sign? A negative number. So I'm going to take out the 2 they have in common, but I'm also going to take out a negative 2. So now we're left with just x and a minus 3. I know I did it right because these two ended up to be the same. So if I factor these out, I'm left with 2x. Actually, let me change colors. I'm left with 2x minus 2 and x minus 3. Now this one's obviously going to be x equals 3 if I wanted to know when it equals 0. This is factoring. what we're now doing is solving for 0. So x equals 3 solves for 0 here. What solves for 0 over here? Okay, well, when does 2x minus 2 equal 0? I add 2 to both sides. 2x equals 2. Divide by 2 on both sides. X equals 1. That's when x equals 0. That's when x equals 0. Let's see if we have more here. We do. So, standard deviation, okay, which is really just mean of absolute deviation, but with the absolute deviation being squared, and then you find the mean of that and then square root it at the end. So, the mean here, if I add these up, I'm going to have 15 plus 7, that's 22, 24. 24 divided by 6, that's going to be, the mean is going to be 4. Okay, the median, if I put it all in order, 1, 3, 3, 5, 6, 7. So the median of 6 numbers, you're going to have, there's 2 numbers in the middle. So you're going to have to add them and divide them by 2. So if I add them and divide them by 2, I'm going to get 4. So 4 is the median. Mode is the number that comes out the most. So mode in this situation is going to be 3. Range is the distance from 1 to 7, which is 6. Okay? Standard deviation is now what we're going to work on. Okay? Standard deviation is first, we're going to do this, and then we'll do that, and then we'll do that, and then we'll do that. Okay? So first, let's find the absolute deviations and square them. So how far is everything from 4 and then square it? So 4, how far is it from 7? 3. Square it, you get 9. How far is 3 away from 4? 1. Square it, you get 1. How far is 5 away from 4? 1. Square it, you get 1. How far is 6 away from 4? 6 away from 4 is 2. Square it, you get 4. How far is a 1 away from 4? That's 3. Square it, and you get 9. How far is a 3 away from a 4? 1. Square it, you get 1. So these are my numbers now. So now I have found the squares of the absolute deviations. Now I have to find the mean of the squared absolute deviations. So I have to add these up and divide by 6. So I get 10, 20, 15. 15 divided by 6. 15 divided by 6 is 2.5. My last step is to square root this. So I square root this, and that's my final answer. The square root of 2.5 is the standard deviation in this information set. All right, next is shading correctly. So this first one, you graph it like you're graphing something that's in slope-intercept form. So I'll graph the first one in black and the second one in red. So this will be the black one. So we're starting on 1, and we're going up 2 and over 1, because the slope can't just go up 2. It just can't be 2. If there's something missing, it's a 1 in slope. Okay, so the slope is 2 over 1. So up 2 over 1. So here is mine, and it's dotted because it's not underlined. It's dotted because it's not underlined. Now the other one, now this is shaded. All of the answers are less than this line. All of the answers are below this line. Now we'll shade that later because I want to know where the dots are for this second thing. So next one, which I will do in red, so then you know which one's the red one. So we start on -2, and we're going up 1 over 5. So the slope looks like this, and it's going to be a solid line because the answers can be greater than or equal to this line. So now, let's shade correctly. I'm going to shade the above one. All of the answers are less than this line. So all of the answers are less than that line. And then all of the answers now are greater than this secondary line. So if all the answers are greater than this line, that means that these are all shaded. Now, the only space that's shaded by everything is this little area here that I'll try to do a little bit more thoroughly than all the other ones. that's where the solution for both lies. Okay, and where they intersect is actually not a solution in this one section because one of them is dotted and one of them is not. So the solution cannot be on the line here, the solution can be on the line here. So if they don't match, then the intersecting point is not the solution set. All right, and that is it. All right.